So what is human geography? What is this all about? Why are you here? So human geography is considered the mother of all sciences. It's the study of spatial relationships, where things occur, and as well as the human interactions with other people, the places that they go to, and the environment that they hold. So they can include questions like, why do people get married, or when do people get married and have kids? Why do urban cities develop along coastlines, and why do rural settlements typically develop more inland? Where do certain cultural groups migrate to? Why do they migrate to those areas, and what are the effects? Who trades goods with certain countries? What do they trade? How does it impact both countries? How does it impact the entire world's economy? What crops can be grown on the land in a certain country? What climate zones are there? How does that benefit the economy as well as the food consumption within the country? How do political alliances affect oceanic boundaries and marine extraction? How does this create disputes and resolutions between countries and organizations? So we're not just looking at, where mountain ranges are, where rivers are, and where countries are, where continents are. We're not looking at just the physical geography. That's very important, though, because physical geography creates our places. However, we're also going to be looking at what humans do to the physical geography and what humans do with each other. So we're looking at human-environment interactions, and we're looking at human interaction with one another within a space. And that's what we mean by spatial relationship. So what can we take away about human geography in this image here? So this is a town in Europe. If you know which country, congratulations. Anyways, what can we conclude about human geography? Well, we can see that there's a certain architecture style. That's a cultural trait between the buildings here. We can infer something about the climate. That's physical geography. We can see the types of trees. I don't know the exact types of trees, but we can see how the humans have handled these trees. They've put them in set clusters here. We can probably determine that there's some parks. They may have them for decorations. We can see that this is a very clustered settlement. The buildings aren't very tall. They're not high rises, but it's still a city area, probably a very historical city area. This is probably in a very developed country, too. So it may have a lot of tourism. It may have a very older population. It may have a low birth rate. So, yeah, there's a lot we can take away from this image. Now, if you didn't understand where I was coming from with any of this, don't worry, that's what you're going to learn in this course. It's just to show you that there's a lot to human geography. I mean, we could go over the political boundaries of the town. Maybe there's two towns technically in this image. We could go into agriculture. What's grown? It doesn't look like they have a lot of farming. Can crops not be grown, or is there just a lower need for agriculture? Maybe they import goods from other countries and export manufactured goods, or they have a high service economy. There's a lot we can take away from just an image and a lot about a place, and that's human geography here. So cartography is the construction of maps, and you're going to see a lot of maps in this lecture and in the entire course. It's very important. So, I just have two maps here to show you. Our first two maps, the population density of Kenya and cancer rates in the world. Population is something that gets its own unit in this course. It's so important to understanding human geography. And we can see that there are clusters of population in Kenya. You can kind of see where populations are very located. And you also see on the world map where cancer is primarily found. We can see that it's primarily found in the United States, Australia, Canada, as well as Western Europe. So those are our more developed countries. Cancer rates are particularly found in more developed countries, per se. There's a higher rate of cancer. And this can create a lot of questions like, why does this occur, and where within these countries does it occur? Because it's probably not the same across Canada and the United States. Those are huge countries. So where are the cancer rates higher? My guess is in the urban centers, obviously, because that's where the more people are. So let's go over some types of maps, because there are specific types of maps. The first one is a reference map. So a reference map is what you think of a map on your college dorm wall or in your teacher's classroom or your kindergarten carpet. It's a reference map that provides a general overview of a location, where things are. Where is Africa? Where is Russia? Where is Mexico? Where are these places located? What physical features are there? Where's the ice? Where's rivers and mountains and other physical landmarks? Where are the peninsulas and where are the islands? Sometimes this map doesn't really show it. There could be political data, like where country borders are, where are urban areas in other cities located. What about transportation routes, like interstates? Where's I-95? And as well as other infrastructure, like train stations and bus depots. Particularly, we don't see quantitative data. We see qualitative data. Qualitative data is data that doesn't deal with numbers here. We don't see a lot of quantitative information on our reference maps here. We don't see like the population of each country here or the size of each country here. And so, yeah, it's qualitative data. So here's another reference map. This one shows more of political boundaries and routes. It shows where airports are located. It shows where roads are located, where railways are located. It shows the boundaries between regions. It shows where cities are. It even shows boundaries between countries like Mongolia, China, and India, as well as Russia. So this is still considered a reference map. We're really only looking at where things are located. We're referencing here. We're not looking at a general theme or a phenomenon. Now, that's the job for thematic maps. A thematic map portrays a pattern or some kind of theme or a phenomenon that's related to a specific subject. And a lot of times, if you Google thematic map, you're going to see population, population density, population growth, population decline, immigration, that sort of thing. Those are very popular thematic map topics. This one is who drives the most. And we can see here that, yes, we see the political boundaries between the states and where the states are located. So we can kind of reference here. But we can also get a actual quantitative value, a number from a research study in 2008 on miles driven in each U.S. state. We can see here that there's less miles driven in California in other states compared to states like Mississippi and Alabama or Oklahoma, where more people are driving here. And some states are just kind of in the middle, like Minnesota, Florida, and Georgia. These types of maps, thematic maps, show qualitative and quantitative data. Remember, quantitative data is data that deals with quantities, which are numbers. All right, that's an easy way to remember it, because that's going to show up again later in the course. All right, so here's a type of thematic map called a chloropleth map. I didn't include the L for some reason. It's a chloropleth map. So yeah, what is a chloropleth map? Well, it's what you think of when you think of thematic map. There's different shades to represent different values here. So we can see here that a very bright blue, or dark blue actually, a more dark blue is more Democrat. A light red is a more Republican. A purple, kind of an in-between, is kind of in the middle. And so yeah, that is a chloropleth map. Here's another chloropleth map. It's on coconut production in the countries. What conclusion can we draw from this map? We can kind of say that coconut production is done the most in our tropical countries, in our more middle countries, closer to the equator. There's a lot we can draw from this map, but besides that, we can see here that chloropleth maps use different shades of color to show different values. Most of the time, the darker the shade, the higher the value. So in this case, the darker shaded countries like Indonesia, Brazil, and India produce the most coconuts. They produce over 10 million coconuts per year, which is a lot. Now, where's a cluster of coconut production? Besides, you can't say closer to the equator, because there's a lot of countries close to the equator, but they don't produce coconuts, like Egypt. They don't produce any coconuts for that matter. Well, they produce like one, but where is a cluster of coconuts? So here we're going to look at our regions. We can see that there's a lot of coconuts being produced in Southeast Asia. There's a lot in India and Indonesia, Southeast Asia. We could say there's a cluster of coconut production. And a cluster, if you don't know, is that's where there's just a lot of it located. There's a lot going on, an accumulation. Now let's look at isoline maps. If you have trouble remembering this, just remember isoline has lines, and you're going to see lines that are not boundaries on these types of maps. So a lot of times these deal with climate and weather, like rainfall, or elevation's a big one, or sometimes temperature or heat. So we can see here that it's kind of like a chloropleth map. We're seeing different shades here. However, they're using lines to separate the values. We're not shading in different states. We're shading in where the temperature changes. So it can vary within a state. It could stay the same within a state. In Florida, there's 3 different average temperatures depending on where you are here. So let's look at another one. This is an isoline map on rainfall within Africa and Asia. Yeah, it's kind of like a chloropleth map. You have different shaded values, but there's a lot of line action going on. And it's supposed to be a little more specific than a chloropleth map. It's supposed to give more specific data for you. It's not used that much either. Dot distribution maps. These are used a lot in local maps. Especially we're locating like where different places are. So this one's homicides in Washington D.C. from 2004 to 2006. I don't know if that's around the same time as the D.C. snipers. It may be a little earlier. If you don't know what the D.C. snipers are, look that up when you have the time. But here we can see different dots have the same value. They mean the same thing, same value. They mean one homicide. The method can be different, like guns, knives, and other, like the key says here. But one dot represents the same value. That's something to take away here, because we're going to look at a map where they don't represent the same value. That's a whole different type of thematic map. And these are really good at finding clustering and dispersals. Dispersals is where stuff's more spread out, and clustering is where they're more close together here. So we can see there's a big dispersal of homicides in the northern areas of Washington, D.C. here. Here's another dot distribution map. This one's population. We can see there's a big cluster of population on the east coast of Australia and northern Tasmania, as well as a dispersal in South Australia or Northern Territory. Or you could say Western Queensland. So yeah, really, really interesting here. And yeah, one dot doesn't have to mean one thing. It can mean 1,000 people. It can mean 200 people. So yeah, we already did that. Cartograms. Cartograms are fun because cartograms change the sizes of the entities with their values. So here we have electoral votes in the 2008 presidential election. And we can see here that California has 55 electoral votes. So they're going to be the biggest entity here. While a state like Mississippi only has 6 electoral votes. So they're going to be really, really small. North Dakota and South Dakota have only 3 votes. So they're really, really small. Compared to a state like New York that has 31, or Florida that has 27. They're going to be a little bit larger. This is another cartogram, and it's very distorted. I mean, look how pinched South America is, and then look how bloated Asia and just Asia really is, India and China area. So what data do you think that this cartogram is showing? What do you think it is? I think, and I know, that it's the world population, because the world population is the greatest in India and China. So these are where these are kind of like your dot distribution maps, but they vary in size. And that just means they vary in value. The larger the size, the larger the value, or a percentage, or a proportion. They're called proportional symbol maps. Sometimes you may see them as graduated symbol maps. So we can see here that a small little rain dot is 1 million gallons per day of water. However, the largest drop is 1,000 million gallons, which is 1 billion gallons per day of water withdrawal. And this is Idaho water usage. So yeah, so where's a cluster of water withdrawals in Idaho? Where are they accumulated? I would say in southern Idaho, there's a cluster. Where's there a dispersal? Northern Idaho, I would say so. Here's another proportional symbol map here. We're looking at population age in terms of millions of people. So the pink represents population under the age of 5, a very large youth population if it's big. And then the orange represents the population over 60. And if that's big, that represents a high elderly population. So in Ireland, they look pretty equal. In Spain and Portugal, that elderly population is far greater than the toddler and infant population. So that's something to consider here. But you can see that kind of as a pattern here across the continent, that this elderly population is magnificently higher than the toddler and infant population. So that could mean something here, especially in Western Europe. So that could show that Western Europe might be aging at a higher rate than Eastern Europe, or that Europe as a whole is aging. And then this is something that you'll see sometimes on like the Weather Channel, is a heat map. And typically this just shows temperature. I don't know where history came from. It shows temperature. The more red, the hotter it is. The more pink, the colder it is. It's pretty simple. You could probably tell if they gave you this on the AP exam and asked you what it's showing. You could probably tell, okay, equator's darker, the poles are lighter, it's showing temperature. All right, let's use a little bit of practice here. So what type of thematic map is this? We'll do a few of these. So this one is showing different shades, but it's also showing lines. So it's showing Spain, France, and Portugal, I believe. And the countries themselves aren't highlighted differently. And the lines vary over time. So this is an isoline map. All right, what about this one here? Okay. We see different dots showing population. What type of map is this? This is a dot distribution map. There we go. Okay, what about this one? It shows different shades across the counties of the United States. It's showing the COVID-19 cases and deaths per county. And these are just different shades. There's no distortion, there's no symbols, there's no dots. This is a choropleth map, clearly. All right, let's move on to some other topics here. We're going to move away from the maps for just a little bit and talk about distance, direction, and location. All right? So absolute distance is a measure of physical space between two locations, or people per se, or two environments. It's what you think of when you think of distance in terms of something like kilometers or miles. You could even do it in nautical miles. And typically we use nautical miles when discussing the ocean or another big body of water here. Your GPS gives you something in absolute distance. Relative distance describes the relationship or separation. It's more of a description between two locations of people. So what could this look like? It could look like a non-stop flight from Rome to Paris is 2 hours. We could describe relative distance in units of time. Oh, it's a 10-minute walk, or it's a 3-hour bus ride. We could also say where something is in relation to where you are. Oh, it's around the corner. Oh, it's down the road. Oh, it's just up yonder. You could say it's a short or a long way away. The beach is a short drive away. The amphitheater is a long ways away. Oh, the gas station, it's not that far. That's relative distance. You could also describe it in other ways, like saying it's more expensive or it uses more resources. Flying to Europe from Florida is going to be more expensive than flying to somewhere like North Carolina. Now let's talk about absolute and relative direction. So absolute direction uses your cardinal points. They're universally understood. And your cardinal points, it's just your compass. Go on your compass app on your phone if you don't know what I'm talking about. It's how the pirates navigated, y'all. So this can include measurements like 48 degrees southeast. That's the direction we have to go in. You could say it's north of somewhere or south of somewhere. Florida is south of Georgia. You could say you need to head southwest to find the buried treasure. You don't need to say the actual degrees. You could just give an actual cardinal direction. Relative direction is another description. It's based off the observer's current position and orientation. So if I move 20 miles, my relative direction may change. So you could say turn left at the stoplight to reach the theater. You're not saying turn west, because turning left depends on where you are. You could say the toy store is 3 blocks away. Blocks are not a set measurement unit. They're not like miles or kilometers. They vary on where you are. Some blocks are bigger than others. You could say Germany is next to France. You don't know where it's next to France because Spain is next to France as well. You could argue that the UK is next to France. It's above France, but depending on what you're thinking about, you could say it's next to France as well. Now let's talk about location. Absolute location is the exact location on Earth a place is. Typically, this deals with two things: longitude, latitude, which I guess is two things. They're your coordinates. That's one thing, as well as addresses, which is newer than longitude, latitude. Longitude is your up and down lines on a map, and latitude are your side to side, your hamburger style They're flat. That's how I think of it. So yeah, longitude, up and down, latitude, side to side. So example of this, this is longitude, latitude. Los Pueblos Hermanos is 35 degrees north, 106 degrees west. You can also give it in the form of an address, like Walter White's house here. It doesn't have to be the whole address. You could just say the zip code. You could just say the city name. It doesn't have to be this long whole thing. So on the AP exam, they ask you for an example of absolute location. You don't have to give this whole thing. You could probably be fine just giving a zip code for one. So just know a zip code, like your zip code. They know it, so they're not going to dox you. Relative location, again, is just another description. If you haven't taken this away yet, the absolutes are the real ones. The relatives are the descriptions. They depend on who you are and where you are. So yeah, a relative location is a description of a place in relation to another place. Like a landmark, you could say it's right by the red fire hydrant. You could say it's in the northern hemisphere. The car wash is next to the law firm. And you might have noticed that these are very similar to your relative directions and distances. And your relative locations can be relative directions and distances. So you can say the house is around the corner from the lab. That's where it's located, around the corner. It could be a direction. It could also be a location. Interesting, huh? Now, did you know that all maps are wrong? Yes, they are. This map that you sat on in kindergarten is technically wrong. Why? There's a good reason. So, the Earth is round. If you didn't know that, now you do. The Earth is round. It's not flat. It's not shaped like a donut. It's not a pyramid. It's 3D. It's a sphere. Not a perfect sphere, but it's a sphere. And maps are 2D. It's like a piece of paper. Well, a piece of paper is technically 3D, but if you print out something, the picture's 2D. Okay? You can't take something that's 3D and make it 2D without having some kind of distortion. You're going to mess something up. Because if I undo the sphere, if I basically like pull it apart and try to lay it flat, it's not going to look like a rectangle. It's not going to look like a flat sheet of paper here. Okay? So as a result, we have map projections. So it's impossible to take a sphere and turn it into a rectangle. So we have what's called map projections, different types of maps that shape the Earth differently. They're a transformation of the 3D Earth to a two-dimensional plane. Every single 2D map, even Google Maps, has some kind of distortion. And there's 4 key areas of distortion. So that could be shape. It could be distance. Our shape could be the shape of the continents. Our distance or the distance between two places. When I look at a map projection, I look at the distances between the continents. It could also be the direction. Is South America actually south of North America? There are some projections where it's more east, where it's just so distorted. And also we look at area. And area is one that tricks up a lot of students. Area technically deals with like the size of the continents. Is Greenland really, really big? Because it's actually not that big. And what do you mean it's not that big? Africa is 14 times as big as Greenland, guys. So yeah. So let's look at the Mercator projection. This is the one you're probably the most familiar with. This is the same one that Google Maps and Apple Maps, they all use this one. And I would just like to know, we're going to go over like 6 different map projections. You don't have to memorize any of them. You don't have to know what the Mercator projection is off the top of your head. You don't need to know what the Robinson projection is off the top of your head for the AP exam. Your teacher might be a little different, but your AP exam, they don't care as much about it. All right? They just want you to know why map projections exist and what they can distort, and then they might give you a projection. Most of the time, it'll be probably the Mercator projection, and they're going to ask you what's distorted. Now, looking at the Mercator projection, what do you think is distorted? I mean, I can tell just by looking at it that Antarctica and Greenland look huge. I mean, the further away you get from the equator, the bigger the land masses get. So yeah, what's distorted? The area, the size of our land masses are distorted. Direction is pretty preserved. That's what makes the Mercator projection so good for navigation, like with Google Maps. Because the angles are really good for navigation. You can use your cardinal directions to get from place to place. And the shapes are pretty well preserved as well. I'll give them that. Now, since direction isn't distorted, we can use this a lot for navigation. Now, let's look at the Robinson projection. No, it's not named after Jackie Robinson. That would be cool, though. This is the Robinson projection. You've probably seen it as well. It's good for posters. So what's distorted? Distance, shape, area, and direction. All of these are distorted. They're all distorted in some way. Minimized, but still distorted. I mean, Greenland and Antarctica still look kind of big. This is called a compromise projection. So everything's distorted, distance, shape, area, and direction, but the distortion is minimized. And they do this to minimize the overall distortion. And it's good to have like for thematic maps because it's visually appealing, and it's now let's talk about the Robinson projection. And no, it's not named after Jackie Robinson, as cool as that would be. So what's distorted here? Okay, so Greenland and Antarctica, they look kind of big. So area is distorted. They kind of look curved. The countries look pretty curved. I mean, look at Greenland. The closer you get to the poles, the more curved they are. So shape is distorted. And that's going to affect your direction because it's curved. And that's going to affect your distance. So yeah. So I didn't say this for the Mercator projection, but your distance is also distorted because area is distorted. If something looks really, really big, you're going to think there's a lot of distance. So yeah, that's just something to know here. So all four factors are distorted here. And that's what makes this a compromise projection. Everything's distorted, but minimally. Minimally means that they are going to minimize overall distortion. So everything's distorted to some degree to minimize overall distortion. Instead of having no distortion in something like direction and having a lot of distortion in area. And that's what makes the Robinson projection visually appealing. That's why you see it on posters, you'll see it online. And it's also very good for thematic maps as well. This is the Gauss-Peter projection. This one is really good at showing something. What is it good at showing? It's good at showing the size of the countries, the size. So what's distorted? Shape, distance, and direction. Size is pretty much preserved, but everything else is distorted here. So yeah, this is not a compromise projection. Since area is preserved, we can kind of see the country's true proportions to one another. So yeah, it makes sense that Greenland is 14 times smaller than Africa. South America is 2 times as large as Europe. And Mexico is bigger than Alaska. All right, now I'm going to show you some really cool projections that I know of. So this is the sinusoidal projection. Oh my gosh, it looks like one of those little tops you used to spin around on the table when you're a little kid. So what's distorted here? Well, Greenland, it looks pretty small compared to Africa. That's always my reference point. So area looks pretty well preserved. South America looks bigger, 2 times as big as Europe. Okay, that's good. Area looks good. But distance is definitely messed up a little bit. Direction is messed up a little bit. Look how curvy this map is. And the shapes, they're curved as well. So everything but area is distorted. It's like the Robinson projection, the Gauss-Peter projection. It's showing the true size of the countries in a different way, but it's distorting everything else. So the Maudlin Integrized Sinusoidal Grid is based on this projection. If you don't know what that is, it's a grid developed by NASA for some science thing. I don't know what it's for, but it's just a fun fact. It's something developed by NASA. So this projection has some purpose here. All right, now let's look at the butterfly projection here. This one's kind of crazy as well, but it kind of looks like a butterfly. What's distorted? Oh my goodness. So yeah, what's distorted? Well, shape is obviously distorted. I mean, look at how curved some of the countries are. Direction is distorted. Clearly, there's a big gap between Europe and North America. Distance is distorted because of that gap, and area is distorted as well. It's one of those compromise projections where overall distortion is minimized, but they attempted to minimize it. This one, to me, has a lot more distortion than the Robinson projection. Let's look at some more. This is the Hammer Retro Azimuthal projection. It kind of looks like a pair of headphones. And that's supposed to be Antarctica, by the way. So yeah, shape, size, distance, direction, everything's distorted. And this is the Collignon projection. Collignon projection? I actually don't know how to say that. I should have. And it looks like a pyramid a little bit. So yeah, this one is used for making maps of cosmic microwave backgrounds. It has some cool science purpose. There's some math behind it. I showed you the equations. There's no math on the AP Human Geography exam, so don't bother learning it. and don't bother learning this projection at all. It's just for me to show you because it's fun. So yeah, that's projections for you. So can you just tell me the truth, Eason? How big are these countries? Well, here's a little picture to kind of show you. And if you like to try it for yourself, go to thetruesize.com. I also made a video on this. If you like to go check it out, I'll put a card above this video. If you want to go watch that, and you can learn the truth about how big some of the countries are. Okay. Thank you so much for watching. Please like and subscribe. It really does help me out, and it costs $0. I have some free resources for you in the description down below if you'd like to use them. If you have any AP Human Geography related questions whatsoever, don't hesitate to leave a comment down below the video or send me a message on Discord. I'll see you guys in the next video, though. Adios.